Welcome to Method Fundament. Today we're gonna integrate two questions, and the first one is the integral of square root of tanhx, and the number two integral is the integral of the cube root of tanhx. I will do that later. And first we're gonna do the integral of square root of tanhx first, and this is not tangent x. Square root of tangent x, I already made a video about how to integrate, but this time we're gonna integrate square root of tanhx, and this is easier. You will see why. This is easier than integrate square root of tangent x. This is the hyperbolic tangents version of tangent. So the first thing we're gonna do is use our use of that u is equal to square root of tanhx. And then square both sides, you get u squared is equal to tanhx. Differentiate both sides, you get 2u du is equal to the derivative of hyperbolic tangent x also is pronounced as tanhx. The derivative of tanhx is equal to secant square x dx. So what's our dx? Our dx is equal to 2u du. Secant square x. Secant square x can be changed to tanhx. Of course, yes, but I kind of forget the identity, so let me just write here. We know the hyperbolic definitions: cos square x minus sin square x is equal to 1. We want something, we want a tanh here. What do we do? Just divide it by both sides cos square x, so you get 1 minus this is sin square x over tan cos square x, you get tan square x. 1 over cos square x, you get secant square x, like that. So far this is just secant square x is just equal to 1 minus tan square x, right? And then divided by sin square x, so this is just 1 minus, and then tan x is equal to u square, and then so this is just equal to u square and the square, so this u power 4, like that. This is equal to 2u du over 1 minus u power 4. You see this is a minus sign. Because this is a minus sign, this can be factor easier. More easier. So you just get this is just equal to u, the original is square root, the original is u, right? Square root of tanhx multiplied by 2u over 1 minus u power 4 du. So you get 2u squared like that, and then here is equal to 1 minus u squared and the square. So we can factor this as 1 minus u squared times 1 plus u squared du. Here, we know how to integrate 1 over 1 minus u squared. We have 3 different versions, right? But I'm not going to tell you first. And we know how to integrate 1 over 1 plus u squared. This is in first tangent, right? So we're gonna split it to 2 fractions so we can integrate, but we can't integrate it yet. So we're gonna use our partial fraction, but let me tell you, we don't need to use the partial fraction here. Let me just write this 2u squared as, let me just write as u squared, we get 2u squared like that. I'm going to write as u squared plus another u squared like that. Here I'm going to write as minus 1 plus u squared plus 1. Negative 1 and 1 they cancel each other out, and then u squared plus u squared is just 2 squared. You will get the original back. So over here we can just split it to 2 different versions. This split into, and the u squared minus 1 over 1 minus u squared, you can just switch the order. Is negative times 1 minus u squared, and this are cancelled. So you put the negative side outside the integral, so you get minus, and then this is 1 over 1 plus u squared, like that. Another one, u squared plus 1 over this. this and this, they cancel each other out. Never mind the order. The order doesn't matter. The order doesn't matter. The order doesn't matter. The order doesn't matter. So split to two different fractions. So you get plus integral of 1 over 1 minus u squared du. Here, the integral of this is just inverse tangent of u, right? In our u rule, and this you can use the hyperbolic tanhx of this hyperbolic tanhx. So this is just plus, but this hyperbolic inverse tanhx u. So the final answers you're gonna get is negative, and then inverse tangent. We're gonna get back to our u rule. Get back to our x rule because we are in the u rule. Now we want to change into our x rule, so we can get negative inverse tangent of tanhx. Seriously, I don't see hyperbolic function often, so I might write wrong. Negative inverse tangent of tanhx x, and then this is just our inverse tanhx, and then inverse tanhx of our square root of tanhx x. Let's see, and that's it. This is the integral of square root of tanhx x. Our second integral is just the cube root of tanhx x. This might be the first video in YouTube, how to integrate square root, cube root of tanhx x. I see someone integrate square root of tanhx x on YouTube. That's Webpan, and another YouTuber, I don't know what's called. You just put down a cube root. To put down cube root, you just put a small phi here, and then we're gonna let u is equal to cube root of tanhx x this time. U cubed is equal to tanhx x. The variables I get phi u squared du is equal to the derivative of this is secant square x. So dx is just equal to phi u squared du over this is just equal to 1 minus u power 4. We've already done it. 1 minus u power 4. And then the original one is just u. So u times that, you get u times u power 3, and then factor it, you get 1 minus u squared times 1 plus u squared. But this time it's harder. We have a u power 3 here, so we can split it to two different fractions, right? So we're gonna use some partial fraction here. And we don't need to just factor it once again, just do it. Phi u cubed. Phi u cubed, sorry my fault. Phi u cubed over 1 minus u squared times 1 plus u squared is equal to 1 minus u squared and then plus 1 plus u squared, like that. So over 1 less the power, the top. So this au and then plus b. And this is just cu plus d, like that. Distribute, you get phi u cubed is equal to au plus b. Because you multiply by this on both sides, so you just get 1 plus u here, u squared here. 1 minus u squared and 1 minus u squared, they cancel each other. And then you're gonna add parentheses cu plus d times 1 minus u squared, like that. So distribute, just expand it. You get, this is just au plus au cubed plus bu squared plus cu minus cu cubed plus d minus du squared, like that. And then we're gonna factor u cubed and u cubed, factor, you get a minus c times u cubed. And then a u square is just b minus d times u square, and then our u is just a plus c times u, parentheses a plus c times u, and then a constant is just b plus d, like that. So over, combine both sides, a minus c is equal to 3, b minus d is equal to 0, another one is just equal to 0, right? B plus D is equal to 0, like that. So far, it's really easy. We already know B and D are 0. B is equal to 0, D is equal to 0. 0. D, it should be D. This ugly. D is equal to 0, like that. Because let me make sure do I make something wrong. B minus D, and then constant is B plus D, nothing more. Because if you want B plus D is equal to 0, and then B minus D is equal to 0, they need to be the same, and then they adding up need to be 0. So they need to be the same either. You know B and D need to be the same, so this and this they also need to be the same. So this. The only situations is B is equal to 0 and then D is equal to 0, like that. So for this, let me just add them up. You get 2a is equal to 3. C and C they are gone. Right? 2a is equal to 3, a is equal to 3 over 2, like that. To figure out where C is just really easy. C is just equal to negative 3 over 2. Because 3 over 2 minus 3 over 2 is just 0. So C is equal to negative 3 over 2. So over you get 1 minus u squared plus 1 plus u squared, like that. U. Just, this looks the same. 1 minus u squared and then 1 plus u squared. This looks really similar. And then the top, AU plus B. But this time B is and D, they are 0. B and D and 0 are 0, and not A and C. The last question, if you use the partial fraction, A and C they are 0. You can do it by your own. This time is different, and this is A is equal to 3 over 2. U, another just 0, never mind. So negative 3 over 2U. So this is really easy. We don't have to do more work. So this is just L1. First you get the L1, right? L1 absolute value of 1 minus u squared. Because, but wait a minute. No, 1 minus something, it can be negative, right? So just put down my absolute value. But we have a 3 over 2 in front. But don't forget, if you differentiate it, you will get 1 over that, and then multiply by the derivative of inside is negative u, negative 2u. So negative 2u, we have to divide by negative 1 over 2. Divided by negative 1 over 2, so this is negative 3 over 4, like that. And then this one, negative 3 over 2. I already write down 3 over 4 like that, because L1, and then 1 plus u squared is always gonna be positive, so just put down parentheses, it's okay. Because when you differentiate this, you will get a 2u inside, right? 2u, you need to divide by 2, so you will get that. So, but we can combine. Let me just write the absolute value here. It will be nice, more nice. Absolute value of 1 plus u squared. So, here's the deal. We have negative 3 over 4 on both sides. Both are negative 3 over 4. So we can factor it out. Factor the negative 3 over 4 like that. And then combine it. But if you factor it, it becomes L1 of this plus that. So you're gonna multiply inside. So let me just write as 1 minus u power 4 like that. 1 minus u power 4 is really cool, right? So what's our u? We can change into our x row now. So 1 minus, I might need to leave some space here. ln of 1 minus, what's u? U is just equal to the cube of tanhx. If you power of 4 raised to the 4 power on both sides, you just need to bring the power inside, so you get 1 minus the cube of the tanhx raised to the 4th power. Or since it can be negative, this entire 1 minus that, it might be negative, so put down my actual value, and that's it. The C. This is really cool. This is the interval of the cube of tanhx, and peace out.